So video 2.14, this will be your last video of your statistics unit. So let's pay attention, get these notes down, and celebrate that another unit has come and gone in algebra. So what is the correlational coefficient? It's a number between -1 and +1, including -1 and +1, that measures the strength and direction of a linear relationship. This is always labeled by the letter R. You're going to be using your calculators to calculate these. You'll see the letter R labeling the correlational coefficient. So it will be a decimal between -1 and +1, and it shows the strength and direction of a linear relationship in a scatter plot. Let's take a look on the next slide of what these look like. So here we have 4 different scatter plots, and I'm going to give you the correlation coefficient for each of them. For this first one, and in your notes, you need to draw these scatter plots and write the correlation coefficient. For this one, your correlation coefficient is 1.00. For the next one, it is 0.71, and I should be saying R equals. For this one, R equals -1. And for this last one, R equals -0.63. If you notice, let's look at our first scatter plot. The correlation coefficient is +1, can't go any higher than that, and the dots make a perfectly straight linear relationship. So that shows a very strong relationship between the data points. It's very constant. It's very reliable. For this one, we still have, if I were to draw our line, I still have a positive correlation, but the dots are not as consistent as with the first one, so our correlation coefficient is 0.71. For the next one, we have them going straight in a constant negative slope, so that's why my correlation coefficient is -1. They are still reliable, concrete points that we can point one after the other and know where they're going to be, but it's going in a negative direction, hence the negative value. And here, again, we see the dots going in a negative direction for a negative correlation, but they're still pretty spread out from the actual line of best fit. So we have a correlation of R equals -0.63, which is a bit weaker of a correlation than this scatter plot here. So the closer it is to either positive or -1, it means it's a stronger correlation. The closer it is to 0 means a weak correlation. So let's answer these questions. When is the value of the correlation coefficient positive? Well, that's when there's a positive correlation, and we can see that in our first 2 scatter plots. When is the value of the correlation coefficient negative? That's when we have a negative correlation. We see that in our second 2 scatter plots. Sorry, I can't spell correlation right here. And is the linear relationship stronger when the correlation coefficient is closer to 0 or closer to 1 or -1? Well, we see from our 2 graphs right here that it's definitely stronger when it's closer to +1 or -1, and like I just said earlier, the closer it is to 0, like these 2 scatter plots here, the weaker it is. So closer to 1, we'll say the absolute value of -1 or 1 is strongest, and then 0 is weakest. So make sure you get these scatter plots down, the notes down, and the correlation coefficients. There are 4 properties of a correlation coefficient, and you need to write these down in your notes. Property 1, the sign of R, positive or negative, corresponds to the direction of the linear relationship. So we saw that. A positive correlation had a positive correlation coefficient, and a negative correlation had a negative correlation coefficient. Property 2, a value of R, +1, indicates a perfect positive linear relationship with all points in the scatter plot falling on a straight line, and we saw that in our first example where the dots went in a perfect straight line. A value of r equals -1 indicates a perfect negative linear relationship with all points in the scatter plot falling on a straight line. And we saw that in our third scatter plot on the previous slide. And then property 4, the closer the value of r is to +1 or -1, the stronger the linear relationship. And conversely, the closer the correlation coefficient is to 0, the weaker the relationship. So make sure you have these properties down. Now, of course, you won't always be given the correlation coefficient. So there is a system on the calculator that is very similar to what we did yesterday with finding our regression lines. And it's the same process for finding the correlation coefficient. So make sure you get these steps down right here so you can use them in class tomorrow to find the correlation coefficient of data. For your hot question, I want you to go back through your notes and find where we answered this question and answer it for me in your hot question response. What does a value of r equals -1 indicate about the relationship of data in a scatter plot? Answer that in your hot question, last hot question of the unit, woohoo, and we will work on this on Monday.